Hello. Hey, in this video, I'm going to show you how to um, make different patterns from circles and squares, right? This is one of your activities. But I just wanted to give you an introduction to it and show you how to make different patterns with two place values and three place values. And then you can try the others that's there, right? So it says, how many patterns can you make with two place values? Two place values means I can only have two of them, right? So how many can we make? So if I put a square there, so there's a square, I can have one more. So that would be another square that I can put there. That's not quite what I wanted to do. Okay, so here, let's click there and move one square there. So now I have two squares. Then I can have, again, I have two place values, so I can have a square and a circle. So how about I put a square and a circle? What else can I have? I can have a circle and a square, right? So there's a circle and there's a square. And then I can have two circles. I can have two circles. And then what else can I have? I can have, I have done square and circle, two squares, two circles. And that's all I can have with two place values, right? If I do something else, it'll be a repeat of the other pattern. I can do a circle and a square, which I've already done. I can do a square and a circle, which I've already done. And so I have done all the combinations. So I have a total of, how many values do I have? I have a total of 4 values, 4 patterns. So I have 4 total patterns, right? So that's all we are trying to say here. We got 4 total patterns. Now I'm just going to move all these things down so I have room to write, hopefully. This way, move it, probably better do them individually. Move it. Okay. All right, we'll come back to the slide in a minute. So that's what I can do. There. That's what I can do with two place values and circles and squares. That's all I can use. Now let's try the same thing with 3 place values. So 3 place values says I can have a square, and I can have another square, right? Then I can have a square, 2 squares, and a circle. Okay, then I can have 1 square. So you can have some kind of a rule. Until you exhaust squares, you do squares. Okay, so squares are all done. Now I'm going to do 3 circles. Okay, 3 circles. Now, are we done? I can have more combinations. What if I start with the circle and then I have 2 squares? That's a combination with 3 place values, right? Then I can have 2 circles and a square, which I haven't done so far. Then I can have all 3 circles. That I haven't done so far. Okay, what else can I have? I can have a circle, square, and circle. I haven't done that so far. Okay, what else can I have? I think I can have, is that all I can have? Do I have 2 squares and a circle? Seems like I have something repeated. That's repeated, so that's not good. But I don't have, instead of that, can I have a square and delete that and a square? I don't have that. So I have 3 squares, 3 circles. 2, 1. Okay, so now I don't think I have any repeated pattern, and I have exhausted all my patterns. I don't think I can have any more. Okay, so I've looked through them. So now with 3 place values, I can make 8 patterns. Okay, And so you try to figure out what I can do with the number of patterns that I have. Now let's go back here to the two place values, total of 4 patterns. What if I considered my square to be a 1 and my circle to be a 0? So what is this actually saying? This is saying this is a 1, 1, 1, 1. And it's going to be hard to do this. Perhaps here's what I'm going to do. I'm going to make a text box. It's easier to do that. Let's insert a text box. Okay. So the square is for 1, then I have 2 1s. If it is a circle is a 0, I'd have 1 0, 0 1, 0 0. So now we have a binary number system. That's essentially what we are getting at. 1 1, 1 0, 0 1, 0 0. Okay. So the 0 0 actually represents a 0. The 0 1 is a 1. The 1 0 is a 2. And the 1 1 is a 3. You will figure out how to do these conversions as you go through. But these are the decimal equivalents of this binary number system. Just kind of similar to this. So a total of 4 patterns. We start from 0 and we go up to 3. Right? So we have 4 values. That's what we're saying. Now let's take the same logic and let's copy this text box and put it in our slide here and apply the same thing for 3 bits, 3 place values. This time I'll start at 0. 0 0 0 is a 0. Then let's go in order. 0 0 1 is a 1. 0 1 0 is a 2. 1 0 0 is a 4. So let's make a 1 0 1, which is a, actually no, 0 1 1, which is a 3. 1 0 0, which is a 4. 1 0 1, which is a 5. 1 1 0, which is a 6. 1 1 1, which is a 7. And that's all I can have. I have exhausted all the bits. Notice I can't have any more, which is what we have done here. 0 0 0, 0 0 1, 0 1 0. So if you go through and follow all of these, you will find that I have all of these patterns in these numbers with zeros and ones. And we go, notice, from 0 to 7. We had a total of 8 patterns. Here also we have a total of 8. But since we start at 0, we stop at 7. This is 8 values. So because we start at 0, our largest value stops at 7. Not 8, but at 7. And the same thing with our 2 place value patterns. We start at 0. I have it backwards, but we start at 0, which is the smallest number. And once we've exhausted both positions with a 1, then we stop, and that's a 3. So we have a total of 4 values, but because we start at 0, our largest value is a 3, which is 4 minus 1. Not 4, but 3. 4 minus 1. Same thing here. Not 8, it's a 7. 8 minus 1. So it's always 1 smaller than the number of values, if you see. So if you were to write this, because our base is a bit, which is 2, it's either 0 or 1, right? Only 2 patterns, right? So you can also write this as 2 to the power of 3, where 3, I'm going to format this to a superscript, 2 to the power of 3, where 3 is the number of the place values, right? 2 to the power of 3. And that will be equal to 8. We all know 2 to the power of 3 is 8. Take away the superscript. 8. 2 to the power of 3 is 8. Say equal to. Right? And the same thing, if I copy that and put it here, 4 total patterns, which is 2 to the power of 2, because we have 2 place values, is 4. 2 to the power of 2 is 4, where 2 happens to be the number of place values here. So that kind of tells you this is the total number of values. Total number of values. And the largest value is 4 minus 1, 3. Smallest value is always 0. The same thing here. Largest value is 7. 8 minus 1, 7. Smallest value is always 0. So 3 place values. So take the same thing and apply it for 4 place values or 6 place values and see what you get. And then you will figure these out as you go through and work with your Flippy-Doos.